Hi, supplementary math lesson for Algebra 2. We're going to be reviewing, lesson 44 in your textbook, Solving Right Triangles. And as we indicated yesterday, we're going to be focusing on, toward the end of this, vectors. And the building blocks of dealing with vectors is your trigonomic functions and how to find the pieces, parts, the components of right triangles. We said a right triangle, any triangle or one of the angles is 90 degrees, and they occur everywhere in our world. So one of the more useful aspects of mathematics in a daily life is actually how to determine pieces, parts, components of right triangles. Okay, and they're much easier if we know those trigonomic functions, as we'll see. If we're building a barn and we're building a lean-to, say, and we need to make rafters or trusses of this, how long do we need to cut those individual parts, and at what angle are they going to be joined together? Okay, maybe we're making a flower bed in the corner of our property. Okay, we want to know how long are the borders going to be. We need the pieces, parts to determine the size of that flower bed, so we know how much mulch to put in there. Okay, or maybe we're putting in some corner shelves in a room. Okay, how big a board, how wide a board, how long do we need to go buy it at the hardware store to do that? Maybe we're putting in a corner fireplace in our room. Okay, how much stone do we need to make the hearth for that fireplace? So just a myriad of options, of possibilities that we might need to know to figure out the pieces, parts of right triangles. Okay, so I constructed one here. We're going to find all of the unknown parts here listed in white of this triangle using our trigonomic functions. Okay, so right now let's go ahead and find this unknown quantity x. Okay, so anytime we look at it, we don't have the hypotenuse length, so right off the bat the sine and the cosine functions are not available because those both need the the hypotenuse to solve for those. Okay, so that leaves us the tangent function. Okay, so the tangent, and the only known angle we have there other than our 90-degree angle is this one here, 31 degrees. The tangent of 31 equals a ratio of the side opposite to it. What is the side opposite to it? It is x, divided by the side adjacent to it, which is 6. Okay, so I need to get the x alone to solve for it. I'm going to multiply by 6. I'm going to multiply by 6. I get 6 times the tangent of 31 will equal x. And I can go ahead and plug that into my calculator. 6 times tangent of 31, x will equal 3.61. Okay, easy enough. X equals 3.61. Now let's find the hypotenuse length. Now, I know from the Pythagorean theorem, I can use the Pythagorean theorem to find that hypotenuse length. Okay, it's going to be 3.61 squared plus 6 squared equals the hypotenuse squared. Okay, if I do my math, it comes out to 13.03 plus 36 equals h squared. Okay, or 49.03. Okay, and if I did more decimals, it would actually be 0.0321 equals h squared. Okay, to solve for h, I'll take the square root of both sides. Okay, that will give me an h equal to 6.9998. Okay, or what I'll say is h will equal 7 when I round it off. I'm just going to use 2 decimals pretty much for all of these trig function problems, okay? And then I'll round it up, okay? I'll round that number, okay? So that gives me basically 7. So I can go ahead and do that Pythagorean theorem method, and if you would like to do that, there's nothing wrong with it, but it's a little bit longer, and sometimes the numbers don't always come out easy. There's several steps to it, okay? There's a possibility of error on each of those steps. Let's do it using our trigonomic function, okay? And again, I'm not going to use this side x because this number is actually rounded to, let's use the exact numbers they give us. So can I use a 6 and an h? Yeah, if I use the cosine function, the cosine of angle 31 equals the adjacent leg length 6 over the hypotenuse, okay? So if I rearrange that equation, I will get h will equal 6 over the cosine of 31, okay? When I plug that into my calculator, what do I get? I get that same number, 6.9998, whatever on down the line. Okay, it equals 7.00. Well, I notice here I had 1, 2, 3, 4, 5 steps to get to the final solution. Here I had basically 1 and then plug it into the calculator. As long as I set up my ratios correctly from the beginning based on the definition of the trig function, adjacent length over the hypotenuse, and as long as I rearrange my equation correctly, okay, but I only have 2 steps basically, and then I'm plugging it into the calculator versus 5 up here. So to me, using trig functions is a lot easier than using the Pythagorean theorem, especially I don't have to deal with squaring and square roots, especially if you're punching that into your calculator. Depending on the format your calculator requires, there's a possibility for error. I know my calculator, putting stuff into the square root one is kind of klutzy. I don't know why they have it, but to do the trig functions is really easy on my calculator, so I much prefer doing that, okay? So what do we have? We have that one solved up here, 7.00, okay? And then let's solve for our angle B up there. So in that case, again, I'm going to use the known exact quantity they gave us, that 6. So I'm going to use the sine function. The sine of angle B is going to equal, what is the sine by definition? Is the ratio of the opposite leg length, which is that 6, over the hypotenuse. Okay, which I calculated at 7.00. Well, even though this is a rounded figure, if I were to use the cosine function, I would be using 2 rounded figures. I'd be using 3.61 and 7.00. Here, I'm reducing my error by only using 1 rounded figure. Okay, so what do I want to solve for? I want to solve for that angle B. It's going to be the inverse sine of 6 over 7.00. When I type that into my calculator, I get B equals 58.9972, or when I round it, B equals 59.00 degrees. Okay. Now another tool I could have used, if you so desire, I could say, well, B is simply, since there are 180 degrees in a triangle, I could say B, since I know my other 2 angles, is going to be 180 minus my 90 degree angle minus my angle of 31. Okay, that leaves me with the B equals 59 degrees. Okay, you can use that tool as well instead of using the trig function, but they're both equally valid. If we know the 2 angles in any triangle, it's simple. Just subtract it from 180, the sum of those angles. That will give me the remaining angles. So that's an easy enough tool to use. So there are the tools that we have. Now let's look again and double check. This was 59 degrees up here. Let's check. Okay, is my longest length in the triangle my hypotenuse? Yes, it is, 7. Okay, is my shortest length opposite of my smallest angle? Is my smallest side length opposite my smallest angle? 31 degrees, 3.61. Yes, it is. Is my medium angle opposite of my medium leg length? 59 degrees, opposite from 6. Yes, it is. So it makes sense by double checking our answers that we have the correct answer. So I hope that helps. It's just a review of exactly what we were doing yesterday. Shoot an email or a text message with any questions. So long for now.